again, the ones on the left could be position or velocity graphs, but I'm labeling number 1 a velocity graph and number 2 a position graph. You guys in the back see okay? I know it's not great because there's a lot on the screen. All right, so here we go. All right, can everybody see them okay? So number 1, this is our velocity versus time graph. And number 2, this is our position versus time graph. For the velocity versus time graph, you're selecting a position graph that would represent the same things. A, B, C, D, E, or F. And here, you've got a position versus time graph. You're selecting the velocity versus time graph that represent the same things, A, B, C, D, or E, F. All right, when you're done, just cover your answers. No one's gonna know but you and me, but I will know, okay? So I need to know. So this is a multiple choice question. It is right off your first test. Let's try and identify information that you have that is useful. If it were me and you wanted to improve, perhaps take a moment and draw question 1 into your notes now. And I'm going to tell you what you should be looking for in order to choose the correct answer. And it may be that we need to be doing more practice. So perhaps I need to increase how much time you spend practicing this. Okay, so let's start at looking at this graph. Is the velocity positive or negative at time 0?
Negative.
It's negative. Excellent. So is the slope of our position graph going to be positive or negative at time 0? It's going to be negative. Does this graph become more negative or less negative? Is it becoming a bigger negative number or a smaller negative number? So a bigger negative number, okay? So I'm looking for a position graph whose slope starts out negative and becomes more negative. Is there a position graph that starts out negative and becomes more negative? I believe there is. There's one I think is close. I look here and I see the slope is slightly negative. Would you guys agree with that sentiment? Over time, does it become more negative or less negative? I believe it becomes more negative. Now, there are a lot of people who chose B as the correct answer here. That's interesting because B starts out maybe 0 or slightly positive and becomes more positive over time. Okay. Now, more of you got question 1 correct than got question 2 correct. But are there any questions about what we just did to try and identify the correct answer for question 1? Yes, ma'am.
So the A is negative because it starts higher and it starts to go down?
No. A is negative because at time 0, so we're talking about time 0 is, this portion of the graph right here, right? So I'm looking at this point on the graph right there. When I look at that point on the graph, I say that slope is slightly negative. That's all I'm looking at. I'm not looking at where it starts. which is going to be important for the next question. It doesn't matter to me where on the position graph it starts. And I'm going to fool you in just a minute to see if I can. And I probably will. But velocity graphs can't tell us where it starts. They can tell us how fast it's going when it starts. That's it. They can tell us the displacement, the change in position, but they can't tell us where it starts. So when I look at position graphs, where they start, this part, here, or even if these are position graphs, the velocity graph can't tell us where it starts. If you're trying to determine that where it starts on the position graph by looking at the velocity graph, you will be disappointed, which is probably why many of you got question 2 wrong. Let's apply the same logic to question number 2. Maybe take a minute and draw question 2 into your notes. The aside is, of the 21 of you who didn't get both answers correct, did you write anything down that's going to help you the next time? I'm looking at papers and I'm looking at what you're writing. You're hearing me, and you think you'll remember. But I don't know that you will. These aren't new things I'm saying to you, and you didn't remember it this time. Are you writing down things? And do you have intention to study these things so that the next time we do this, you won't make this mistake? And I'm not saying this in any way to be facetious or mean. I know that if I give you 100 practice questions over the next 3 days, you'll get better at it. But I know there's 6 of you who don't need to do 100 practice questions to get better at it. Now, where are you on this scale? You understand where I'm going with this? If not, I'll make it clear. Practice. Do you need me to direct you to practice? I will. But that's why I gave you all a textbook. There's lots of practice in the textbook. Did you look at it? Chapter 2. Tons of stuff. I don't teach from the book, but I gave you a book. Look, try. But let's talk about question number 2. Now you have it drawn in your notes. Is the slope of this graph positive or negative at time 0? Well, that's not very many of you, so that's concerning. So I'm going to ask again, look at the position graph. Can you determine at this location, by just looking at it, whether the slope is positive or negative? Is it positive? Yes? Is it negative?
Yes.
All right. Is the velocity of the object positive or negative? There's our problem, right? You should be Johnny on the spot with that answer. Slope of position is velocity. The slope is negative, the velocity is negative. If you don't know that, you need to know that. This is why you're getting them wrong. I think you guys chose C because the object started in a positive location, and so did C. But you'll notice graph C has a positive velocity at time 0. Do you guys see that? I'm looking right over here. Right there, that's a positive number. So because that's a positive number, I don't think that graph matches up at all, even though so many of you chose C. I think you chose C because we know that C and D are similar. They both have a point where the object is clearly stopped, and you recognize this graph as having some of those features, but not the right ones for this argument. The object starts with a negative velocity. It eventually has 0 velocity, and then has a positive slope, which means positive velocity. That's why D is the correct answer. I said that I think I can fool you. I'm going to try, okay? So let's see. Give me a moment to try and fool you. So, let's That's going to have to do. That's terrible. That's going to have to do. And that's terrible, but that's the way it goes. All right, try again. Again, I'm trying to trick you on this one. Let's see, I'm looking at the first graph. At time 0, is the object's velocity positive or negative?
Negative.
At time 0, the object's velocity is positive. I'm looking right here. This is a positive number. The slope of this line is negative. But this is a velocity versus time graph. So the object's velocity is positive. But you heard it, right? I'm not trying to trick you. I know it feels like it, and I even said I was. But this has a positive velocity at time 0. Is that becoming a bigger number or a smaller number over time? So I am looking for a graph that has a positive slope and whose slope is becoming a smaller number over time. So when I look over here, this one has a negative slope, can't be it. This one has a 0 slope or a very small number, and it's becoming more positive over time. That's not what this is. These are straight. I'm not even going to look at them. Don't think they're here. This object's slope is changing. But E has a very positive slope, and it stays positive but becomes a smaller positive number over time. The answer is E. Again, I'm not trying to make this hard. I just know that you're not looking at the right things, and there's a lot to keep track of. This object has a negative acceleration. The slope of the velocity graph is negative. And the slope of the velocity graph does have meaning. I just didn't ask about it. Now, I could ask you to find an acceleration graph. It would not be very interesting, by the way. The acceleration graph for this would look like that. Here's an acceleration graph that would go with question number 1. Acceleration versus time. A negative number that is constant. Right? The slope is negative, and it's the same number all the time. I've never put this on the screen before. I've never talked about them. I'm not trying to trick you. I'm just saying you're looking at the wrong thing. So get that out of here because I don't want to confuse you. Question number 2. We already just saw this one. Question number 2 isn't any different because the graph is in the negative section of the position portion. The velocity graph is still going to be about the slope of the position graph. So is the slope positive or negative here? So I need to find a velocity graph that starts in the negatives. Could be this one, could be this one. I'm going to notice that at some point the object stops. All right, that doesn't narrow down D or F because we can say F stops and D stops. But do you notice that if you keep going, the object eventually has a positive velocity? That over here, the slope is positive. So I need to have a section of my graph that also has positives. It's the same graph. I wasn't trying to, this is the part I was trying to trick you at. And the trick is this. Those two functions are going to have the same velocity graph. Velocity graphs can't tell you where they start, but they can tell you about how the velocity changes over time. Both of these have the same changes in velocity over time. Doesn't matter that one started at the starting line and went backwards, or one started far away from the starting line and went backwards. It's the fact that they both went backwards that matters. Not trying really to trick you. I just know it feels that way. So, your notes and what it is that you need to do to get better. I think we can probably identify a couple things. First, you need in your mind to differentiate what a velocity graph tells you and what a position graph tells you. You're getting them confused. I know it doesn't feel that way, but that you are. You are attempting to guess your way through it. I know it doesn't feel that way, but you're like, well, it's got to be one of the curved ones because. But you don't have any reasons there. Have you noticed that I start in the same place every time? You should start in the same place I'm starting. What kind of graph is it? Start there. If it's a position graph, slope is velocity. That's simple. If it's a velocity graph, its values are the slope of the position graph. You need to know the difference.
Could you repeat that?
Sure. If you're looking at a position graph, its slope is the velocity. If you're looking at a velocity graph, its values are the slope of the position graph. Again, not trying to trick you. I mean, there's more. There's more things that we know. For example, we know that the slope of the velocity graph is the acceleration. A velocity graph can tell you acceleration. A position graph can hint at it, but it's hard to find it. I didn't even talk about it very much because it just hints at it. There's more. There's things where we haven't even started yet, like area. Area has meaning. But if we're just trying to pick out which graph goes with which, that's enough. You probably should put somewhere in all of this that a velocity graph can't tell you the starting position. Can't. So stop trying to say that those two things are related. You guys do it all the time. There are people in this room right now who thought that because this one started at 0, that they had to pick a graph over here that started at 0. I know you're out there. I saw your answer. Those are all the people who chose B. Incorrectly, by the way. All right. I could keep doing this all day, but I think I've made my point. I want to go a little further. I think we need a little bit more to see where our mistakes are. I've discovered several of your mistakes. And we're happy this isn't an actual test. So let's see if I can discover some more mistakes. And you guys who came in for help this morning, I hope that this is helping. It might be humbling, but I'm hoping it's helping. Because between you and me, I really didn't want to do this today. There were other things I would have preferred to have done. All right. I've given you some information, have I not? Could you tell me the distance traveled by the object? I'd like you to do all three of these things. I believe you kind of have to do them anyways to do the position versus time graph. But I'd like you to tell me how far the object went, its distance traveled. But I'd also like the displacement. I want you to demonstrate you know the difference. And I would like you to carefully sketch a position versus time graph. So have labels on it that show me, you know, what the object did, where it went. Start the object from the origin, please. And I don't want this to take very long. I'd like you to get on this one. If you don't know what you're doing, break out your notes, but don't ask your friend. Make this all you. Tomorrow we might work with friends. A little bit of practice. I'm going to try and review some of the things that we've talked about. This object, does it have a positive velocity or a negative velocity at time 0? Okay, I look right there and I see a positive velocity at time 0 right here. Is the object speeding up or slowing down? It's a trick question, isn't it? Slows down for 2 seconds. Would you agree? Because at 2 seconds, its velocity is 0. Then after 2 seconds, it speeds up. But now it's going in the positive direction or the negative direction. So it goes forwards for a little bit, and then backwards for a little bit. I would argue it goes forwards for 2 seconds and backwards for 4 seconds. Some of you don't know that because you didn't do that part correctly. Based on the graph I have here, I could probably determine a few things about its motion. For example, I could find this area, which would tell me the displacement in the first 2 seconds. And it's a triangle, so 1/2 base times height would give me positive 10 meters. Any part about that I need to talk about that need to be more specific? Base is 2, height is 5, it's 10. So 1/2, 2 times 10 gives me 10. I didn't see this mistake anywhere, which is good. Nobody shaded this. You might have used that, but that's not the area. The next area is here. That's the next area, which has got a base of 4 seconds, not 6 seconds. Right, 2 to 6 is 4 seconds. So 1/2 times 4 times 20 gives me negative 40 meters. So my object moved forwards 10 meters and backwards 40 meters. That's a total distance traveled of 50 meters. Now if it goes forwards 10 and backwards 40, that's 50, not 60. There's a whole lot of you with 60 out there. I'm not sure where that comes from. I think I know, because a lot of you think that the object ended up at the negative 40 meter mark. And that's not true either. I'm just calling it like I see it, though. Displacement in 6 seconds, negative 30. Now, look, if you need a formula, I don't like to do this, but I'll give you one. If you can find the areas, just add all the numbers together, make them all positive. That's distance. If you want a formula, if you want a way that you don't have to think about it, you want just an answer, something you could do formulaic-like, but not have to think about it. Find the areas, make them all positive, add them together. That's the distance. That'll get you the correct answer. It won't always mean you understand what you're doing. If you want the displacement, add the numbers together, but keep the signs. That'll give you the displacement. Or use the trapezoid formula. That would have worked here. 1/2 sum of the bases times the height. 10 plus negative 20 times 6 times 1/2. Now, if I want to make my position versus time graph, the first thing I'm going to do is I'm going to identify the same places in time. It has to be a graph of the same thing. So it has to have the same events. So I labeled my 2 seconds and my 6 seconds. I told you to start the object from the origin, so time 0, it's there. A lot of you started elsewhere. That's fine. If you started in the wrong place, the rest of the graph should look the same as mine. In the first 2 seconds, it moved forwards 10 meters. In the next 4 seconds, it moved backwards 40 meters. 10, 20, 30. Right? That would be, that distance has to be 40 meters in the negative direction. At 2 seconds, it stopped, slope of 0. At 0 seconds, positive slope. At 6 seconds, negative velocity, negative slope. That's not very beautiful, but serviceable. Better. That's my expectation for this one. The bell rings in a minute. I think that we will practice tomorrow. And I think that you will be served by practice tonight. So rather than moving forward with the homework I was going to assign, we're going to do some more of this. I want to nail it. I don't want you guys to feel like you can't do it. Have I